Assalamualaikum warahmatullahi ta'ala wabarakatuh. Salam sejahtera. A very good day I would like to bid to everyone. As for today, I'm going to present on our group's innovation idea entitled Geometric Morphometric Analysis of Cervical Vertebra, a novel method for assessing sexual dimorphism at Malaysia. My name is Faiz, Fauad. I am a postgraduate student from Faculty of Medicine, Universiti Islam Malaysia, USIM. Other researchers that involved in this project are Dr. Asbalillah Alias from Faculty of Dentistry, Universiti Islam Malaysia, USIM, followed by Dr. Ku Mastura Ku Muhammad Noor from Faculty of Medicine, Universiti Islam Malaysia, USIM as well, followed by Dr. Choi Kerwun from Faculty of Medicine, Universiti Teknologi Mara, UiTM, and last but not least, Dr. Ng Wei Lin from Pusat Perubatan Universiti Malaya, PPUM, Kuala Lumpur. This is the poster of our recent project that has been conducted in order for us to achieve the innovation idea that we are planning to introduce later. As for introductions, forensic anthropology is a field of study which focuses on systematic human remains identifications, primarily human skeletons. And when we talk about this forensic anthropology, there are four important biological profiles that need to be established for the sake of human identifications. The first one is sex. We've got to know the bones are owned by either male or female groups. Second one is from which ancestry the bones are coming from. The third one is what are the estimated age or the age groups of the bones. And last but not least, how was the stature before of those skeletons that has been found. One of the ways or methods that often used by forensic anthropologists to facilitate them in the process is known as morphometrics. Morphometrics can be simply defined as the study or the analysis of shape or form of an object, and it can be further divided into two types, which are traditional morphometric and geometric morphometric. For traditional morphometric, this is a conventional method that still using calipers manually to measure the bones. For example, the width and length of certain bones, and these measurements will be used for further analysis. However, it consumes a lot of time as the researchers need to collect the bone, clean the bones first, and classify them individually before being measured. Apart from that, a lot of money and labor force need to be allocated to implement this type of method. Therefore, to solve these problems, we would like to introduce and highlight an innovations idea involve forensic investigations, particularly on cervical vertebra, known as geometric morphometric analysis. For geometric morphometric, as the name implies, we are analyzing the bones geometrically, meaning to say that we are using Cartesian coordinate system, for example x and also y, or x, y, and z, to quantify bone variations that will be used for further analysis. Basically, what we need to do is just putting the landmarks on selected points of the bones presented on certain digitalized images such as X-ray or CT scans, and these points usually will be outlining the periphery part of the bones, covering the bone shape as a whole. So because of that, it's more time and also cost effective as compared to traditional morphometric method, and the original shape of the bones is able to be maintained. By having said so, geometric morphometric is more reliable and feasible to be conducted. Moving on to the objective of our project, first, we want to develop a new method based on geometric morphometric to quantify cervical shape and also size variations. Next, we want to explore if there are any sexual differences or sexual dimorphism in terms of third cervical vertebra morphology, both size and also shape, between male and also female. As regard for methodology, a total number of 432 lateral cervical X-ray have been selected to be included based on our stated inclusion criteria, which are both male and so female of three main ancestries that present at Malaysia right now, Malay, Chinese, and so Indian, that age from 20 to 60 years old. we have excluded those patients who are with cervical malformations, abnormalities and fractures, any history of cervical surgery done before, and non-Malaysians. Geometric morphometric analysis was performed on those selected X-rays to explore third cervical vertebra morphology, sexual dimorphism between different sets. This is the example of cervical X-ray that has been selected in our study. We focus on third cervical vertebra. 11 landmarks were put on the selected points of the vertebra by a software, namely TPS Digitalized 232 software. As we can see from this figure, these landmarks or points were actually outlining the periphery part of the bones, covering the bone shape as a whole, producing a new geometric information of third cervical vertebra shape that will be used for further analysis. Conceptually speaking, the collections of these new geometric information of third cervical vertebra were processed with few analysis techniques, namely generalized procast analysis, principal component analysis, procast ANOVA, and discriminant function analysis by Morphometric software. And these analyses were meant to visualize the third cervical vertebra morphology, both shape and also size differences between male gender and female gender. Moving on to the results of our project. First, procast ANOVA have showed that both centroid size and the shape of third cervical vertebra morphology were significantly different between male and also female, with p-value less than 0.0001 respectively. Apart from that, more than 17% of both male and also female were correctly classified under their own sex groups by discriminant function analysis. As we can see from this figure, male groups were distributed more on the right side, whereby female groups were distributed more on the left side. Just a small portion of them were overlapped between each other, and this manifesting to us that both male and so female were discriminately different in terms of cervical morphology. Moving on to the discussions. As we discussed earlier, geometric morphometric analysis is more promising, is more reliable and so accurate because it is able to maintain the original shape of the bones. It is a quick method and cheaper as compared to traditional morphometric method. In addition, it is a highly conducive method to be implemented, especially in the condition where massive data is needed, such as in the vast disaster phenomena like tsunami and also earthquake. Our study has found that there was a significant difference between male and also female in terms of third cervical vertebra morphology by geometric morphometric analysis method. Apart from that, more than 17% of them were correctly classified under their own sex group, and this is apparently higher as compared to other bones, for example like carpal bones, which only 61.8% of them were correctly classified under their own sex groups. Our study was in agreement with one study conducted by Tadzigiani and so Haluzinitis on 2014, which they have found that both size and the shape of cervical vertebra were significantly different between male and so female. Finally, we reach into our conclusions to wrap everything up. Geometric morphometric analysis of cervical vertebra is a new method, is a new innovation that conducted on a selected database by few analytical software such as Morphometric software to aid or to facilitate the forensic investigation process. This new method has few advantages, which is more reliable, okay? It is more cost effective and also cheaper as compared to traditional method. So because of this extra value, geometric morphometric should be considered and it is more feasible to be conducted in forensic diagnosis. These are our references. That's all from our groups. Thank you for your attention.